Hello class, and welcome to this video R session. In this short video we're going to be going over classes in R. So get settled and let's dive in. Okay, so we're doing classes in R. Now what is this? By now we are familiar with RStudio, right? And the analogy of the kitchen, where R is our little chef existing in a world that is a kitchen. And RStudio gives us access to that world, lets us talk to little R and tell R what to do, whether that's we're talking to R right just directly in the console on that bottom left quadrant of RStudio, or we're typing out a good recipe, instructions for R to follow step by step with notes for us thinking about what we're doing in the R script. Now, we also know that the environment, that top right quadrant in RStudio, is our kitchen counter, right? It's kind of the things that we have allowed R to, prep, create, and store for future use. We're like when we create things and put them as objects in the environment, we're manifesting them, creating them in the world of R for future use. Now, all these things, all these objects, anything really that we can create in this world that we put on our kitchen counter, that we store in our environment, has a type. R looks at the world, and from R's eyes, it understands everything. It looks at something and says, oh, I can have a type to that. That is a fruit, right? Or that is a liquid like soup. Or that is a vegetable. Or that is a whole category of onions, right? And the onions are different types. There's the shallot, there's the red onion, yellow onion, etc., right? It looks at things in types and understands them in those categories. That's what a class is, right? Now, it's kind of like, just like you wouldn't store soup in a basket, R understands that. So it looks at soup and says, oh, that's a liquid. It goes in this container, right? That's how R is using classes to understand how to store them in the environment and use them in the future. So, the two most common types or classes in R, the default is the numeric. And this is just any number with decimals, right? So it can have infinite amounts, get smaller and smaller and smaller. This is, 5.0. It's also 3.14, etc., in pi. And this is the default, usually, that R sees most of the world in. That having been said, there are also integers. Now, integers are also numbers, except for they are whole numbers. They cannot exist in decimals, right? Sometimes it's better to use integers rather than numbers in order to save space if you're working with really huge data sets, right? And if the data sets are super huge, it's easier for R to process and work with them if they exist in whole numbers. Now, there is another class that we're going to talk about called character class. Now, this is anything that lives between quotations. It's text or strings of text that exist between those quotations. So let's dive into RStudio to take a closer look.
Okay, so here we are in R, and as you can see, I created a new R script here called classesscript.r. .r is the file. It's indicating that it is a script. I did so by clicking right here for new file, then clicking R script, and then a new one showed up. I then saved it in my my files by saying Control Save. You'll also see that up here I have used that hashtag to create some notes, just telling me what the title of this R script is, this recipe, right? Continuing with our kitchen analogy, and what it's for. Now, let's start by making some character class objects. A character object, as discussed, is just a string of text. When we say character string, then we mean a kind of like string of letters. And so I'll start off by first just making a note saying making character class objects start with my name. Now I'll say name. Use this arrow here oh, this was old stuff. So if you ever want to really just, this is from before, if you want to, a previous R session, if you ever want to kind of clean all this up, because I'm not using these today, you can press this broom here. This will clear all the objects away. It'll say, are you sure you want to do that? Even hidden objects, which honestly, I don't know exactly what that means. Just say yes. And then all of a sudden now I have nothing here, right? Now my counter is completely clean, entirely clean. Everything is gone. Now, back over to my script, I'll write name, and then I will start my character string by using the quotations. And as I start to type, you'll see that it is in yellow. And there is my name. If it is between two quotation marks, there can be spaces, no big deal. All of this right here becomes one character string, right? And I can even write that here. This is a character string. So excited about it, right? Now I can double click this in order to highlight the entire line of code. Press Control Enter. R runs it down here. Only that which was before, right over here, before the hashtag, because hashtag indicates stop. This is now a note. And then I have name, and there it is. Let's create another one, right? You can do, how about my Oxy office? Office. Now this is in white because it's becoming an object that we're going to put over here on our kitchen counter environment. The arrow, less than sign, and then the minus sign, which looks like an arrow, obviously. And then again, I actually, in order to do a character string or a character class object, you can use the double quotations or you can use the single quotations. Either one works. You'll see that they both turn up in yellow. And I will say Johnson 307. And highlight it, Control Enter, and run. Now, if I wanted to make an object that would have all of my contact information together in one object in one space, kind of like a list of all my important contact stuff, my name, my office, maybe my phone number, I could do that this way as well, right? Maybe first I'd say my fake phone number, because I don't want to put my actual phone number on YouTube, and I'll say phone, little arrow. Again, I'm going to put this in quotation marks because I don't want it to be an actual number. Making it an actual number could make things a little bit confusing for R. All of my contact information will be the character class objects, and so I'll say 555 6678. Now, highlighting that, Control Enter, R runs it, and now I have three objects over here, my name, my office, my phone. But let's say, again, I want to have all of this information in one list for contact info, right? Then, let's say, create it's a character vector, which is essentially just a list of things, a list of objects in R. Create a vector of my contact information for R. And then I say contact info and make a little arrow to put things in it. Now notice here that I did not put a space. If I had put a space, this is going to get confusing. And there we go, an error is going to show up. It's very confused because this looks like essentially just an object, but that object doesn't exist over here. So R doesn't know what it is. But by going this way, all of a sudden, like, oh, you're creating a new thing. Now the error, the thing is showing up here because now nothing is over here. And it's like, wait, put what there, right? But we're going to calm down, R, we're going to do it. And we'll say C, remember? And now we're using R, this first command that we've talked about being the combine kind of command. And essentially, again, this is going to, there's a video on this as well, but this is going to create a list by kind of putting all of these objects and what's inside them together in one bigger object in order, right? And so I will say name, comma, office, comma, phone. The commas are important here, right? This is kind of creating a list, right? So without those commas, it doesn't understand, or this is just one object. What's happening here? What do you want to do with this space? That comma tells it this is one item, and this is another item, and this is another item. Now, if we do this, now we have a new little object here on our kitchen counter, and it is a list of character strings, right? There are 3 of them, and they're ordered, right? So the way I ordered them here over in my script and ran it down here is the way they're going to show up. It's going to be name, what my office is, and the fake phone number. If I had done it, for instance, try a different order. I'll say contact info 2, right? Just for comparison, create my arrow, use my C again, make the parentheses to tell it what to combine, and I'll say name, phone, office this time. Run it, control enter, and now you see as it shows up here on 2, it's still a character object, a list of character strings. There are 3, but it says Professor Lizzie Weiner, and then it says my phone number, and then it says Johnson, right? So this is different because the list is in a different order. All that to be said, the order makes a difference.
Okay, now that we have that in hand, let's move things up a notch to the factor class. So factor class is super important in R. And essentially it's like the extra special category class where you're telling R, these aren't just random things like male or female. They're not just like random words in the string class variable. They're in fact different levels of one larger category. And I want you to pay really close attention to the levels R, right? I want you to pay close attention to whether this is male or female. These are 2 levels of the same category, and they are either like one group or the other. An example building on the kind of kitchen metaphor is if we wanted to create a big container of onions that needed to be balanced or something between shallots, red onions, and sweet onions. So instead of seeing a lot of shallots and red onions and sweet onions kind of randomly as just words within that bowl, I could tell R no. Recognize shallot, red onion, and sweet onion as 3 different levels or types within the larger category onion. Then, once R sees it as, oh, these group together and are importantly grouped together, and I should distinguish between each one, I can ask R to be like, hey, are we overpowering here with the red onion? Do we need more sweet onion and shallot? Like, what's the balance between each of these 3 categories? When you make a factor class variable, R can do that for you, right? So essentially, factors are creating kind of levels within an important category, enabling R to analyze and look at everything within those categories in terms of group, rather in terms of a big pile of objects. Let's see in RStudio.
Okay, here we go. Now, we're back in RStudio. We're in the same place, right? We still have the contact info and the name, office, and phone elements on our kitchen counter here in our environment, right? But I have then added to the script and pre-written it here to make things easier and more time efficient. We're going to run through a script here that can demonstrate the relevance of factor variables, right? Specifically, who cares, as is in the notes, right? The notes are always telling us what we're doing. So I want to see how things get easier for R when we're using a factor class rather than, for instance, a character class, okay? In order to do that, I'm going to chop some onions.
Okay, so here I am again. Hello. And a second ago I was talking about onions and chopping them and shallots and like what? This is what I was talking about. We're about to literally ask R to cook for us, to prepare Like, let's imagine we're cooking for 500, 800, okay? And we need a lot of onions in a big, big bowl of different types. I'm going to say R, chop up all these onions. But then I'm going to want to know how many of each type of onion is in the bowl, right? Understanding how that task is challenging for R, or more challenging when it's just a bunch of onions and I have to like take them out one by one and count them. Or if I can understand categorically and look at the whole thing and just count into 3 types as R can as a computer, it'll make things easier. So let's take a look.
Right. Thank you, Professor Weiner. Okay, so I'm going to chop some onions, right? I'm going to create a huge vector, aka container of onions, huge. Now, the way I'm going to do that is I'm going to tell R these are 3 types of onions, and I want to draw a certain number of times from that list of different kinds of onions and put those draws into a new container, right? The number of draws is how many things go into the container, right? And things I'm drawing from are, I'm going to create a list of onions, right? The way to do, and I want to do this randomly, right, as close to randomly as possible. Now, computers actually can't do true randomness. Instead, what they do is they have a huge algorithm with a long, long, long list of what appears to be random numbers. They're close to random, but they're not technically true random, right? Now, I'm going to do this thing called setting the seed. Setting the seed tells R, I'm going to say 1, 2, 3. Setting the seed then tells R where in that long infinite list of numbers I want R to start, from its quote unquote randomness, right? And so that'll essentially mean that anytime in the future, if I want to create the exact same list that I'm about to do, I can just set the seed to 1, 2, 3, and I can do the same thing all over again, right? So that's reproducibility. Now, first things first, let me give R a list of onions that I want chopped, right? I want shallots, I want red onions, and I want sweet onions. I put those, combine them with our C command, and name this thing onions. These are the types of onions I want to cook with. I highlight it, press Control Enter, and lo and behold, onions are on our countertop, right? Different kinds. Now I'm going to tell R to chop the onions, which in other words is doing that sampling thing. I'm going to have R take 100 million draws from this list of 3 onions, right? And anytime it takes one away from the list, I want it to put it back to, right? I don't want anytime a red onion is taken for there only to be shallots and sweet onions left, right? Otherwise, we can only get a sample of 3. So I'm going to say replace equals true. The things in here are the different necessary components that have to go between the parentheses for this command sample. We haven't done this command, but this is a command. You can learn more about it by going down here. I'll say sample. Or I'll be like, oh, sample, yes. And then you'll see it says, in order to do this, you need X. What am I sampling from? The size, how many samples do you want? Do you want me to replace things once they're taken from the sample? And this is probability. Null means that you don't need to say anything. If the probability is null, right, and it is null for us because we don't include it in our commands, then every single thing in the list that we provide has the same probability of being sampled. If I don't want that to be equal, I can put something and say, oh, okay, probability, I want sweet onions to have a higher probability of being drawn, and then it'll do that, right? But we don't want to do that. So I'm going to delete this. And I'm going to run here. I'm going to draw 100 million times. Oh, and 100 million, how do I know that? Because 1E8 means 1 with 8 zeros. Now, I'm going to put it in a thing called Big Onion Bowl. That's the object that I'm going to put on the countertop, and it's going to be that big. And now I'm going to highlight, no, not everything, just this line, double click, only line 30 will be run, Control Enter, and look, it's going. Oh, look, it's taking a while. Do you see, remember that stop sign? Stop sign means R's still working. I can push the stop sign and stop R. So R's still going. This is taking a bit of time. Still going. Okay, I saw this little caret come up, right? This greater than sign, and the stop sign's gone. Then eventually, Big Onion Bowl showed up on the counter. It's a large character. Yeah, it's large, right? Specifically, It has 100 million elements inside of it. And this is its computer size, which I don't quite understand, but that's how big it is. All right. Now, let's make that big bowl of onions, which is all characters, into a factor class, right? Which will require R to look through the big bowl, identify how many unique things are in there, right? How many categories of onions there are, count them, and then assign them into levels, right? Put them into categories. It can do that, and it'll create a new factor variable that is now the big factor onion bowl, where everything in there is categorized rather than just being on its own a string of characters. Now, I highlight it. This as factor means take this big onion bowl, which is currently a large character, and make it a factor variable instead. Just do what I just said. Okay, so, and I'm going to put it in a new bowl. Control Enter, and once again, it's taking a bit of time, right? Time. Still going. The bells are ringing. Oh, we've got it, right? Now, we see it's a large factor, and this many elements, 100 million, once again, right? Same amount, but it's half the size. Right? It's half the size, which is easier already for R. Let's see how much easier. Let's tell R to look through the bowls, sort out and separate all the red onions, and also then tell us how long it took to do that, right? That's what this code says, right? It says, I want to create a little box of only the red onions. I want you to separate them. So I want you to find which, parentheses, and it says which of big onion bowl, right? This big bowl over here, equal red onion. Okay, remember that means that's the logic command of equal. Now, this command up here, system time, you see has a parentheses right after it. That means it's a command. And if I put my cursor right next to it, it'll highlight the other parentheses with which it's associated, right? So everything within here and here is this command. And it's saying how much time. System time means tell me how much time it takes for you to do whatever inside of here, right? Whatever inside of these squiggly brackets. And then this is the command I want, and tell me how long it took. So, not going to take a short amount of time. And it's going to tell me exactly how long it's taking. Okay, so user, this is what it prints out down here in the console. The time elapsed, this is elapsed, it took 3.45 seconds to do the whole thing. That's nuts. It also took the user, which is R, 1.31 seconds to figure out what the devil was even going on. Let's ask it to do the exact same task, right? Count, or sort out, identify which within the big factor bowl equals red onions, right? Put those into a new bowl, just the red onions, but they're factors, and then tell me how long that took. Right? This time, instead of doing the big onion bowl, that's the character, we're doing the big factor bowl, and see if it takes less time. It's not going to take a short amount of time because that's a huge amount of stuff, but it took less, all right? It only took 0.79 seconds for R to figure out what's going on, and then 2.04 seconds to do the whole thing versus 3.45 seconds with the big onion bowl that didn't have things as a factor. That doesn't seem like a big difference, but it's a huge difference. That is an enormous amount of time for a computer that can do all this stuff instantaneously, right? And this is an important point. When we make things a factor, we're making them a category, and it makes the whole process of analysis for R a lot easier. That's why we care about factor variables.
Okay, so we've gone over now different kinds of classes in R. We've done numeric versus integer, super simple. We've then taken a closer look at the character class. And then we took an even closer look at kind of introducing ourselves to the factor class. The next one we're going to cover as a class is going to be the data frame class. Now this is a whole new animal, one that we haven't quite dealt with yet, so it's going to need its own video. I want to say also that there are so many classes in R that you can specify. We're going to go over the basic ones that we need to know, kind of like if we're getting into our day-to-day R use. But the more advanced you get into R, the more kind of crazy classes that can exist if you need them to be like, hey, R, this is a special kind of thing that exists in your world. I'm going to classify it as such. Give it a specific class. But we can keep it to our simpler ones. And for next time, though, we're going to kind of, once again, up the ante a little and do data frames. So looking forward to that video. Looking forward to seeing you. Stay tuned. Thanks.